and is global. This is the third part of the mathematics in which we'll include the important formulas for the numerical methods. Let's begin one by one. Here first one is the solution of algebraic and transcendental function, or you can say that finding the roots. In that first one is bisection method. This method finds the root between points A and B. Here if f of x is continuous between A and B and f of A and f of B are opposite sign, then there is a root between A and B. Then second one is first approximation to the root is x1 is equals to a plus b by 2. Then if f of x1 is equals to 0, then x1 is the root of f of x is equals to 0. Otherwise the root lies between a and x1 or x1 and b. Then similarly x2 and x3 you can determine. So here simplest iterative method. Then bisection method always converges but often slowly. Then this method can't be used for finding the complex roots and the rate of the convergence is linear. So these are some key points for the bisection method. Now let's move towards the next method, which is Newton-Raphson method, or you can say that successive substitution method or tangent method. Here the equation for the Newton-Raphson method is xn plus 1 is equals to xn minus f of xn divided by f dash xn. So this is the most favorite method for the examiner in every exam which are conducted recently for the engineering field. Then after this method is commonly used for its simplicity and greater speed. Then here f of x is assumed to have continuous derivative f dash x. Then this method fails if f dash x is equals to 0. Then it has second order of convergence or quadratic convergence. For example, the subsequent error at each steps in the proportional to the square of the error at previous step. Then sensitive to starting value. Here the Newton-Raphson method converges provided the initial approximation is chosen sufficiently close to the root. Then last one is the rate of convergence is quadratic. So these are the key points for the Newton-Raphson method. Then after the third method, which is secant method, this is the modified version of the Newton-Raphson method. Here xn plus 1 is equals to xn minus xn minus 1 divided by f of xn minus f of xn minus 1 into f of xn. So if you write down in the form of 1 and 0 by putting the value of n is equals to 0, then this equation will be very easier for you to understand and for remember. Then after here some key points. Convergence is not guaranteed for this secant method. Then after if convergence, then convergence superlinear. It means more rapid than linear and almost quadratic like Newton-Raphson method around 1.62. Here 1.62 is the rate of convergence. Then here the last method is regular Falsie method. So you can also say that the method of false position. Here for this method, first of all there are some key points. Regular Falsie method always converges, then however it converges slowly. Then after if converges, order of the convergence is between 1 and 2, then it's near equal to 1. Then after next point is it is superior to the bisection method. Here if given that f of x is equals to 0, then select x0 and x1 such that f of x0 and f of x1 less than 0 and having opposite sign. Then after x2 is equals to x0 minus x1 minus x0 divided by f of x1 minus f of x0, and f of x0 is equals to x0 into f of x1 minus x1 into f of x0 divided by f of x1 minus f of x0. Then after here check that if f of x0 and f of x2 less than 0 or f of x1 into f of x2 is less than 0, then compute the next term which is x3 here, which is an approximation to the root. Then after next topic is solution of system of linear equations. Here the first method is Gauss elimination method. Here equations are converted into the upper triangular matrix from the solved by back substitution method. Here consider that a1x plus b1x plus c1z is equals to d1, similarly d2 and d3. Then step 1, to eliminate x from the second and third equation, and here we do this by subtracting suitable multiple of first equation from the second and third equation. So the next step is eliminate y from the third equation, and the third step is the value of x, y, z can be found by back substitution method. Here note that the number of operations n is equals to n cube by 3 plus n square minus n by 3. Then after, the next method is Gauss-Jordan method. Here some key points are there. It is used to find the inverse of the matrix and solving linear equations. Then here back substitution is avoided by additional computations that reduce the matrix to diagonal form, then instead to triangular form in the Gauss elimination method. Here the number of operations is more than Gauss elimination, as the effort of back substitution is saved at the cost of additional computation. Here step 1, eliminate x from the second and third. Then step 2, eliminate y from the first and third. And step 3, eliminate z from first and second. Then after, the next method is LU decomposition method. Here it is modification of the Gauss elimination method, and it is also used for finding the inverse of the matrix. Then Ax is equals to LU x is equals to b can be written as, first one is L into y is equals to b and u into x is equals to y. Here this is the representation of the LU decomposition method. Then solve y from a, then solve x from b. Then this method is known as Doolittle's method. And then similar methods are Crot's method and Cholesky methods. Then after, the next one is iterative method. In the iterative method, two types are there. First one is Jacobi iteration method. Here this is the equation for the Jacobi iteration method. Then if a1, b2, c3 are large compared to the other coefficients, then solving these for x, y, z respectively will get these three equations. Then after, let us start with the initial approximation x0, y0 and z0. So we'll get finally these three equations. Then here one note is there, no component of x raised to k is used in the computation unless y raised to k and z raised to k are computed. Then the process is repeated till the difference between two consecutive approximations is negligible. In generalized form, these three are the equation for the respective terms x, y and z. Then after, the next method is Gauss-Jordan iteration method. Here it is the modification of the Jacobi's iteration method. It starts with x0, y0, z0 is equals to 0, 0, 0 or anything. Here no specific condition. Then in first equation put y is equals to y0, z equals to z0, which will give x1. Then in second equation put x is equals to x1 and z is equals to z0, which will give y1. Similarly, in the third equation put x is equals to x1 and y is equals to y1, which will give z1. Here note that to compute any variable, use the latest available value. In generalized form, these three are the equation in the form of x, y and z. Then here the next topic is the numerical integration. This is the most important topic for the examination. Here three methods are there. First one is Trapezoidal Rule. Here step size h is equals to b minus a upon n. Then integration x0 to x0 plus nh f of x dx is equals to h by 2 into in bracket first term plus last term plus 2 into all the other terms. This is the most important equation for the examination. Based on this equation, more than 4 to 5 times questions were asked in the exam, so you must have to remember this equation. Then here error is equals to exact minus approximate value. Then the error in approximating An integral using trapezoidal rule is bounded by minus h square by 12 into b minus a into maximum of f double dash of zeta, where zeta belongs to mod ab. Then the second one is Simpson's 1/3 rule, or you can say that Simpson's rule. Here the equation is integration x0 to x0 plus nh f of x dx is equals to h by 3 in bracket first term plus last term plus 4 into all odd terms plus 2 into all even terms. So here h by 3 is there. These three equations we have to remember for the trapezoidal, then Simpson's 1/3 and Simpson's 3/8 rule. Here the equation is like integration x0 to x0 plus nh f of x dx is equals to 3h by 8 in bracket first term plus last term plus 2 into all multiple of 3 terms plus 3 into all remaining terms. And the equation of the errors are also given for 1/3 and 3/8 rule. Then after, the last topic of this lecture is solving the differential equations. Here two methods are there. First one is Euler method, which is for first order differential equation. Here given equation is y dash is equals to f of xy, then y of x0 is equals to y0. Then solution is given by yn plus 1 is equals to yn plus h into f of x and yn. Then the last method is Runge-Kutta method. Here in the Runge-Kutta method, third order and fourth order two types are there. So here as you can see that in the third order Runge-Kutta method, yi plus 1 is equals to yi plus h by 6 into k1 plus 4k2 plus k3, where k1 is equals to f of xi yi, then k2 is equals to f of xi plus h by 2 and yi plus h by 2 into k1, then k3 is equals to f of xi plus h and yi minus k1h plus 2k2h, where h is equals to xi plus 1 minus x1 is the step size, then local error is of order h raised to 4 and global error is of order h raised to 3. Then after the Runge-Kutta method for the fourth order, or you can say that the classical method also. Here it is used for finding the y at a particular x without solving the first order differential equation. Here dy by dx is equals to f of xy, then k1, k2, k3, k4 and the value of k are given here. So finally k is equals to 1 by 6 into k1 plus 2k2 plus 2k3 plus k4 and y of x0 plus h is equals to y0 plus k. This is the final equation. Then here this table is useful for the examination. Here for the trapezoidal, Simpson's 1/3 and Simpson's 3/8 rule. Here DFP means degree of fitting polynomial is 1, 2 and 3 respectively, and OM is equals to order of method, which is 1, 3 and 3 respectively for the trapezoidal rule, Simpson's 1/3 rule and the Simpson's 3/8 rule. That means for first degree trapezoidal rule is more accurate than that of Simpson's 1/3 rule, and for the second degree or third degree equations, Simpson's 1/3 rule is more accurate than that of Simpson's 3/8 rule as well as the trapezoidal rule. Here as you can see that degree of fitting polynomial is equals to 1. That means the trapezoidal rule will give you the correct answer for the first degree equations without any error. Similarly for the Euler's method, Runge-Kutta of order 2 and Runge-Kutta method for order 4, here the order of error and order of method are given. So for the Euler's method, order of error is 2 and order of method is 1. Similarly for the second order Runge-Kutta 3 and 2 and fourth order Runge-Kutta method, order of error is equals to 5 and order of method is equals to 4. So you have to remember this value because sometimes this value can be asked directly in the examination. Here as you can see that there is one example also there for the fourth order Runge-Kutta method, or you can say that classical Runge-Kutta method. Then these are some advantages and disadvantages for the Simpsons 1/3 rule versus Simpsons 3/8 rule. Here first one is advantages. It can use an odd or even number of subintervals rather than just an even number of subintervals as used in the Simpsons 1/3 rule. So here 3/8 rule's advantages are given. Then it can converge to estimated integral values much quicker than Simpsons 1/3 rule. Then it has the same order of accuracy as Simpsons 1/3 rule when calculating the absolute error, but Simpsons 3/8 rule is actually slightly more accurate, but the fraction used in this error will be smaller and then will provide a more accurate error. Then these two are the equations for the 1/3 rule and 3/8 rule. Then disadvantages are this rule requires multiple of 3 segments only, and when calculating the value by hand, this rule is more complicated. So this is all about the third part of the numerical ability, in which we have covered total 4 types of questions. In the starting, we have seen the solution of algebraic and transcendental equations or root finding, then after solution of linear system of equations, then after numerical integration, and at the end solving differential equations. So if you like this video, please do like and subscribe to our channel for the upcoming videos. In the next part, we will discuss about the quick revision for the calculus, which is part 4 from total 6 part of the mathematics. So please share this video to the maximum study groups and press the bell icon for the upcoming video. Thank you so much. Hope for the best. Good luck.